Continuing on with example 4. It says, given triangle ABC, draw the dilation with a scale factor of 1.5 and a center at 5, 8. The previous example that we looked at, we did something very similar to this, but the center was at the origin at 0, 0. And so we could use our rule of basically using our scale factor as our multiplicative factor, and we figured out what the coordinates were for our 3 points, and we multiplied them all by that factor, whatever that factor was in example 3, and we figured out where our new coordinates were, and we had our dilation. So again, the rules only really work when the center is at 0, 0. But I'm going to show you a different way of doing this, kind of how we could do this with rotations, when the center is not exactly at 0, 0, but we can still use our rule. So here's what I'm going to do. I'm going to find where 5, 8 is at. So first, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So here's the point 5, 8. Now here's going to be kind of the weird thing that I'm going to do here is we're going to pretend that this line, vertical line, and this horizontal line, except I need a horizontal line, not another vertical line, thank you. We're going to pretend that where the point 5, 8 meets, right here, we're going to pretend like this is really 0, 0. So pretend that this is really 0, 0. Now, technically, our rules will apply to multiply by our scale factor. Now, here's the thing. We're going to have to pretend that this is 0, 0, so we need to figure out what are the coordinates for A, B, and C when we pretend that this is really 0, 0. Okay? So let's see. A, it would be pretending this is 0, 0. This would be 1, 2, 3, 4, 5, 6, 7, negative 7, comma, 1, 2, 3, 4, 5, negative 7, negative 5. Now, is point A really the point negative 7, negative 5? No, it's really, what, negative 2, comma 3. But using our pretending origin, it's really negative 7, negative 5. Okay? And again, we're doing this so that we can just multiply our x and y by our 1.5. Okay? So let me go ahead and write what B, the pretend B and C would really be here. So B pretending would be, what, negative 2, negative 3. And C would really be 1, 2, 3, 4, 5, 6, 7. So really we move nothing left or right, but we move down 7. So now I can take my scale factor of 1.5 and multiply it by the x and y coordinates on each of these. All right, so after I do that, then let's see, A prime would end up at negative 7 times 1.5 would be negative 10.5. And negative 5 times 1.5 would be negative 7.5. So now, where do I start graphing these points from? Do I go to the real origin or the pretend origin? We would go to the pretend origin. So from the pretend origin, we're going to go left 10.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5. And then go down 7.5. 1, 2, 3, 4, 5, 6, 7.5. So basically, I'm like right in the middle of this guy right here. Okay, so there's where A prime really is. And what are the real coordinates of A prime if I really wanted to know what they were? Well, really, from the real origin, it would be 1, 2, 3, 4, 5.5, comma, a half. Right? I'm moving over 5.5 and up just half a unit. That's really where A prime would be. Okay, and if I just wanted to look at this, we should be able to see that our pretend origin, the center, to A prime, should all line up, and they do. So this truly is a dilation factor here. And I'll show you something else with that later. So B prime. Again, if we take negative 2, negative 3 times 1.5, that would be what? Negative 3.5 in the x, negative 3.5 in the x, and negative 3 times 1.5 would be negative 4.5. Except I did that wrong. Negative 2 times 1.5 isn't 3.5, it's 3. So it would just be negative 3, comma, negative 4.5. So from my pretend origin, I'm going to move over negative 3, down 4.5. So right here would be B prime. And then same thing for C. We multiply the 0 and the negative 7 by 1.5. So we're still at 0 in the x direction, but negative 10.5 in the y direction. So again, move nothing left or right, but I move down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5. And there is C prime. So now if I connect together A prime, B prime, B prime, C prime, C prime, A prime, what we need to check, we said all dilations are similar to each other. So does it appear that this triangle, ABC, and this larger triangle, A prime, B prime, C prime, does it look like that they really are similar to each other? And some things that you could also ask yourself besides just appearances, what you should notice is true that's happening every time is, for example, notice AC and notice A prime, C prime. What do you think is true about the slopes of those two segments? And if you said, hey, they look like they're parallel, you would be correct. And the same thing is going to happen for all the other segments, like AB and A prime, B prime. Those should be parallel. And BC with B prime, C prime. Those should also be parallel. So if all of them look like they're parallel, we're in pretty good shape here. Now, the scale factor of 1.5, another thing I want to show you here, and we'll look at the A's. From A, let's get a different color here. From A back to the center, this is like a scale factor of 1. This is how much 1 is worth. Now, if I want to do 1.5, that means that this extra bit beyond A to A prime must be the half factor. Okay, so this will always, from your point that you're wanting to dilate back to your center, that's always a scale factor of 1. So this must be the extra 0.5. Okay, and that's going to lead to the second way that I'm going to show you how to do this same problem when we don't use a pretending origin. So this is one way of doing it. This is much more mathematical of actually using the rules that we used before in the previous video. But we had to pretend that we had an origin that we really didn't have. And we counted everything from that pretend origin. So now, let's go back to square one. So now I'm going to show you how to do this problem without worrying about a pretend origin. So again, let me find 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So here's 5, 8. There's our center. And everything is going to grow at a 1.5 factor from this center. So everything should be pushing out in this direction, right? Because we already know what it looks like. Now, the thing I'm going to use is basically the idea of slope, all right? So if I go from my center to point A, and it doesn't really have to be slope. It doesn't have to be rise and run. It could be running and then rising. Either way is fine. And just to illustrate that point, I'll run and then rise. So if I went over 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4, 5. So if I started at my center of rotation and went 7 to the left and then down 5. Well, how would I do a dilation with a scale factor of 1.5? Well, these would be the two numbers that I would need to multiply by 1.5. And I'm going to go in those same directions that I went before, to the left and down, but whatever these numbers end up being. So 7 times 1.5 is 10.5. And 5 times 1.5 is 7.5. So really, back from the center of the dilation, which is my 5, 8, I really want to move to the left 10.5 and down 7.5. So let's go over 10.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5, and then down 1, 2, 3, 4, 5, 6, 7.5. And it's that same point that we ended up at earlier. Because, right, we really graphed the point, negative 10.5 comma negative 7.5 when I showed you with the pretend origin. And that's what we really did. So doing it this way is kind of like we get to skip a step, because we really didn't need to know necessarily what the coordinate of A was when we really just used the slope of it. And so using the slope, we kind of get to ignore the positive and negative aspect of that. Because I didn't really call this going down negative 5 and going to the left negative 7 as I would if I really wanted to graph those as points. So now what about with B? So with B, if I start at my center, I'd have to go, what, right, or not right, left 2. If I go left 2 and then down 3. So from the center, left 2, down 3. Again, what do I need to do with those numbers? I need to multiply them by my scale factor. So multiply each of them by 1.5. Really, I need to move to the left 3, and I need to go down 4.5 is what both of those would equal. So from the center of rotation, I'm going to go, what do we say, left 3, 1, 2, 3, and down 1, 2, 3, 4.5. And there's where B prime is, once again. For C, really I just needed to move down, I believe it was 7. So if I move down 7, again, I need to multiply that by my 1.5 scale factor, which is 10.5. So basically just move down 10.5 from the center, from the dilation. So there was 7, 8, 9, 10.5. And there's C prime. And so now I can connect together my A prime, B prime, B prime, C prime, C prime, back to A prime. And I've got the same picture that I had before. So there's two different ways to go about doing your dilations when the scale factor is not at 0, 0. You can pretend that your center is really 0, 0 and do all your math from there, or we can use this idea of slopes. Now, another kind of cool thing that I can illustrate here is if I connect together all my pre-image and image points, they should all connect back to the center because that's where all the growing and shrinking came from, right? That was our root for our growth or our shrinking. So one thing you could kind of do that's kind of cool here, if I could pick any point along this line, let's say I pick, I don't know, this point. And if I were to make a parallel line from this point over across here, does that look like it's about parallel to A prime, C prime? I think it's pretty good. I could call, let's say, this point A double prime, and I could call this point C double prime. And now I need a B double prime somewhere, right? So if I went, so notice how A prime, B prime looks here. If I started at A double prime, I would need to make this line parallel to AB and A prime, B prime. And I would say, what, about right in here? About right in that vicinity? It looks pretty parallel to the others. So if I call that line B double prime, and then connected that B double prime to that C double prime, then notice how these triangles look like they're telescoping out, right? There's ABC. Here was A prime, B prime, C prime. And now I can look at this, and I don't even know what the scale factor is of this. I could figure it out, but I know it's definitely bigger than 1.5. So I could keep going on and on and on and making all these triangles get bigger. But I mean, this is kind of a cool aspect here. This also illustrates all the parallel line motions here between A prime, or between AB, A prime, B prime, A double prime, B double prime, and then all the lines of BC, B prime, C prime, B double prime, C double prime are all parallel. Likewise with AC and A prime, C prime, and A double prime, C double prime, all of those lines are parallel. That's always going to be true. And as all of these segments continue to go back, eventually they just turn into the point, 5, 8. All right, the last problem we're going to look at. So it says, determine the scale factor and the center if I give you the pre-image and image coordinates. Now, I'll be honest with you, figuring this out without a graph is pretty tough. And if you want to explore those ideas, you can knock yourself out. They are not easy at all. So I would recommend doing this type of problem graphically. So let's graph all our points out here. So A is at -3, 4. So here's A. B is at -5, 7. 5, 6, 7. There's B. And C is at -9. Let's see, that was 5, 6, 7, 8. -9, 4. So there's C. So let me go ahead and let me move. Let's move this guy over. Put A right there instead. So let's look at, here's triangle ABC. Now let's look at where triangle A prime, B prime, C prime is located. So A prime is at 6, 1, 2, 3, 4, 5, 6, negative 2. So again, there's A prime. B prime is at 1, 5.5. 1, 2, 3, 4, 5.5. And C prime is at, that should be a comma right up there, negative 9, comma, negative 2. So negative 9, negative 2. There's C prime. So let's connect all those guys together. There's A prime, B prime, C prime back to A prime. So do we have a scale factor that's bigger than 1 or smaller than 1? Well, it's definitely going to be bigger than 1 because our image triangle's gotten larger. So we definitely know we're dealing with a scale factor that's greater than 1. And where's the center located? You know, that's, we don't really know. It's not 0, 0, right? Things weren't growing or shrinking from here. But just like what we mentioned in the last example, if I get to the last example, there we go. If we connect together all our image and pre-image coordinates of each point, they should all lead back to the center, right? If we connected together A prime and A and kept going, and B prime and B and C prime and C, all of those segments, all of those lines led us back to this one singular point, which was our center point. So let's do the same thing with these guys. So let's connect, let's use what? Let's use red here. If I were to connect B prime back, why did it stop? Just use the good old mouse here. B prime back towards B, and I'm just going to make it keep going back. Somewhere back along here, somewhere backwards of B should be the center. We don't know exactly where yet, but we're getting there. So now if I connect A prime to A and make it keep going back, at this point we can stop because we know that it's got to be this point right here is where the center should be. Now, if we want further validation, further proof, we can connect together C prime with C and make it stretch further back, and it also crosses at that same point. So again, this point right here, this must be the center point. So let's figure out what the coordinates of that are. Well, it's negative 9. This was negative 9, 4, so this is 5, 6, 7, 8. So the center is at negative 9. This thing will let me write. Negative 9, comma 8. Could you figure that out mathematically without necessarily graphing it? And the answer is you can, but it's very, very complicated once again. So I would recommend just graphing the points and seeing where do all the image and pre-image points of the same letter, like B and B prime, A and A prime, C and C prime, where do they all connect back to? And that's going to be where your center is located. So that takes care of the center, but now we got to figure out the scale factor. Now, this is something that I, again, mentioned in the previous example, where I said this distance between a pre-image and the center, this is like saying a scale factor of 1. So from B to the center, this much is a scale factor of 1. And from the center to C, this was like a scale factor of 1. So if we go back to our problem that we were looking at here, well, from our center at negative 9, 8, let's grab, let's say green. From the center to B, this is like saying a scale factor of 1. We need to figure out how much more this is so that we can add that onto our 1. Well, I'm going to use the idea of slopes. This is going to be one way I'm going to do it. I'm going to use the idea of slopes. So from the center of the center of the dilation to point B, I'd have to move down 1 and right, what, 4? So if I went down 1, right 4, that looks like an awesome 1, 1 and 4. And then let's see what I would do to get from the center to B prime. So it looks like I'd have to move down 1, 2.5, right? Because B prime was right in that half area. So down 2.5 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it went down 2.5 and over 10. Well, now here's where I get to do just a little bit, this thing will stop being crazy on me, a little bit of math. This is where I need to look at, well, 1 really got multiplied by what to get to 2.5? Likewise, I should get the same number here. 4 times what would give me, I know that looks like a 16, but really a 10. And it should be, again, the same exact number, which is 2.5. And that's my scale factor. Now, if you wanted to make sure that it was really 2.5, you could do the same thing with A and A prime or with C and C prime. And I think it's actually going to be easier to do if you look at it in terms of C and C prime, just because it's vertical here, right? So this was 1, 2, 3, 4. So if I went 4 down, that's like saying a 1 scale factor. But if I went down another 5, 6, 7, 8, 9, 10, altogether, this was 10. So again, 4 times something, our K scale factor, should give me 10. And if I divide over by 4, I'll get 2.5 or 5 halves or 2 1/2. So I get the same thing. The place where people mess up on is they look at this as 4, and then they look at this and go, hey, this is 6 more. So now let's take 6 divided by 4, and that's 1.5. But that's not the scale factor. You need to go back to your center every time. Okay, so the center to our pre-image coordinate of C that I erased, that was 4, and then the center down to our C double prime was 10. That's where you want to do your dividing. So again, line up all your pre-image image coordinates, see where they all meet back to. Boom, there's the center. To figure out the scale factor, you can use this idea of slopes, or you can set it up a little bit more algebraic if you choose. And that's it for all of our transformations.